Hey everyone, here we are going to be covering shaping processes for plastics. So to start things off, we have polymer melts, which serve as the starting point for many of our plastic products. They are non-Newtonian behaving fluids, which exhibit pseudoplastic behavior. Now moving on to our first manufacturing process, we have extrusion, which is a rather straightforward high volume application where plastic is just heated up and pushed through a die. And so here in these two images, we have an example of vinyl drywall corner bead. And so the corner bead is formed again by plastic being pushed through the die to get the appropriate corner bead shape. And then the plastic coming out is immediately cooled in water. The general extruder machine components include a hopper, barrel, screw drive, and screw drive motor. Now moving on to advantages and disadvantages. First, we have the form, which is limited since we only can have long continuous shapes. So that could be a disadvantage. The lead time is also weeks, which is a bit long. However, the cycle time is short since again, we have a high volume process. So that means that the cost per part is also going to be low. However, due to the machine cost, the initial setup is quite expensive. So now moving on to our next process. Here we have polymer foam processing, which involves expanding a polymer mixture using blowing agents, which create cavities in the foam. And there are three general stages for this process, which include cell formation, cell growth, and cell stabilization. And so we can see a diagram below depicting this process. And so for foam processing, we have three general methods, which include physical, mechanical, and chemical foaming. And to the right of each method here, we have a diagram for the process. And so now for advantages and disadvantages for physical, we have low cost and pollution free as some advantages. However, there are high technical requirements and special machines needed, which is a costly disadvantage. Now for mechanical, the equipment is simple and easy to operate. It is low cost and high efficiency. However, there are high requirements on the equipment itself. And lastly, we have chemical foaming, which can be carried out with an ordinary injection machine. However, the disadvantage is that the mold cost is high due to the necessary precision requirements.
And for injection molding, the process goes as follows. The mold is created at first based on the part that needs to be manufactured or produced. Then the material gets injected inside of the mold. Afterwards, it gets cooled down. After the cooling, we eject the part from the mold and we trim the excess materials. Injection molding, just like other manufacturing processes, has its own advantages and disadvantages. And um, one of the advantages is the volume that parts can be produced in really high volumes, which reflects on revenues positively. The complex geometries that can be produced through such process and the materials used. We can use a high range of materials, thermoplastics, to produce the parts. On the downside, injection molding has its disadvantages too. Some of those are the high initial cost, which is the equipment required for the injection molding, the lead time for tooling, which means that the mold could take a lot of time to be produced before starting to produce the parts. Um, Compression and transfer molding are kind of share a lot of similarities too. Um, so the process for both goes as follows. We prepare at first, uh, decide how much material we're going to use, what thermoplastics, and all that. If we're going with compression molding, then we compress the material. If not, we transfer it to another mold and then compress it as well. After the compression or transfer, then compression is done, curing happens, which is heat and pressure are maintained on the mold. And when it's done, of course, cooling happens. Some advantages and disadvantages of compression and transfer molding are also shared as well. So some of those are they're really great to manufacture large parts. Um, the cost of equipment is a little bit less compared to injection molding, and the maintenance for the molds require less maintenance. Disadvantages of both compression transfer molding is less volume can be produced compared to injection molding. Um, high labor costs and high labor costs as it requires a lot of human input. A lot of materials go to waste, and of course, less precise dimensional control.
I'll be discussing sheet and film production and fiber and filament production. Sheets and films are usually produced using extrusion methods, where the sheet stock is usually between 0.5 and 12.5 millimeters thick, and film stock is thinner than 0.5 millimeters. There are three main extrusion processes: slit die or chill roll extrusion, which is the top left picture; blown film extrusion, which is the right picture, used for garbage bags and packaging film; and calendering, the bottom left picture, usually for the creation of products like shower curtains. Some advantages of this type of production process are that it is cost-effective and continuous high-volume production, has excellent accuracy and thickness control, and can be used in a variety of applications, and has robust isotropic strength. Some disadvantages are that there is a very high starting cost because of the specialized equipment and tooling. It needs a close watch over the temperatures, pressures, and rotational speed of the polymers and tooling as to not break the flow of production, and although cheap and high volume runs, it is costly for small-scale production. Fibers and filaments are produced by spinning, a term carried from the natural fiber spinning before synthetic production was available. Fibers are strands of materials at least 100 times longer than the cross-sectional area, whereas a filament is a fiber of continuous length. There are three methods for this type of production: melt, dry, and wet spinning. Melt spinning is highly applicable in spinning heatable polymers like polyester and is similar to conventional extrusion methods. However, there is significant thinning when the polymer becomes molten, resulting in possible material loss. Dry spinning is suitable for acrylic fibers, where the solvent evaporates, keeping the setup very clean. However, it requires a heated chamber for the solvent to be evaporated, posing environmental and safety concerns. Wet spinning is similar to dry spinning, but it is used to create rayon, where the solvent is non-volatile, reducing product loss. However, the polymer material must still pass through a liquid chemical to coagulate, requiring additional equipment.
Hello, I'm Rahim Shafiq. Today I'll be explaining blow molding. It is a manufacturing technique that utilizes air pressure to expand soft plastic within a mold cavity. It plays a crucial role in mass production of plastic bottles. It is a two-step process. First, fabrication of molten plastic parison. Second, inflation of parison to the shape of the final product. There are two types of blow molding: extrusion blow molding and injection blow molding. Extrusion blow molding is a highly automated process. It has a high production cycle. Advantages include that it is technically more feasible and economical. It is usually required that a blow container is rigid, and its rigidity depends on wall thickness and other factors. Assuming that our final product is cylindrical, we can use following equations for the process. Firstly, to calculate swell ratio and Tm, which is the thickness. Observation of extrusion and die dimensions allow for calculations of wall thickness in blow molded containers. Next, we'll be talking about injection blow molding. It is an alternative to extrusion where parison is injected molded. The advantages include high production rate, greater accuracy in dimensions, lower scrap rates, less waste material. Another technique, stretch blow molding, includes the stretching of parison for stronger products. The advantages include more rigid structure, higher transparency, better impact resistance. Next, we'll be talking about the materials and the products that are used in blow molding. Blow molding is limited to thermoplastics, which include high density polyethylene, polypropylene, polyvinyl chloride, and polyethylene terephthalate. Products that can be made from blow molding include large shipping drums, large storage tanks, automotive gasoline tanks, toys and hulls for sailboats and small boats. The most widely used material for stretch blow molding is polyethylene terephthalate. Next, we have another technique, rotational blow molding, a molding process which utilizes gravity within a rotating mold to create large hollow shapes. It is primarily used as an alternative to blow molding, commonly employed for thermoplastic polymers, thermosets, or elastomers. It is a four-step process. Firstly, we load polymer powder into the split mold, then we heat and rotate mold on two axes for even coating. Then we let let it rotate to solidify the plastic and cool down. Then we open mold to extract finished product. The advantages include that it is suitable for complex geometries, large parts, thermoplastic, thermosets, and elastomers. It is very efficient and fast, similar, simpler, and less expensive than other molding methods. And it increase productivity with simultaneous multi-mold processing. Materials include polyethylene, polypropylene, and high-impact polystyrene. The products that can be made using rotational molding are toys, marine, recreational items, automotive components, furniture, and storage containers.
Polymer thermoforming is a process where a heated thermoplastic sheet is made to conform to a shape, either using a force or a vacuum. The main processes are material selection, where a suitable thermoplastic with a certain thickness is chosen to be used. Then the mold itself is prepared by either putting on a release agent to prepare sticking, or it's controlled thermally. Then the material itself is heated up uniformly to allow for manipulation of shape. It is formed using a force or a vacuum. Then it's cooled and the excess is trimmed off. The advantage of this process is it's a very cost-effective method with a very quick turnaround time, and it also has design flexibility, as the positive mold can just be switched out at any given point. A disadvantage is that it needs to be relatively thin gauge plastic, as making thick shapes get heated up uniformly and make them bendable is quite difficult. You also have limited material options because they have to respond to heat in a way that could help with the thermoforming, and you usually get very low detail with this process because small crevices are hard to fill. Casting is a process where a plastic is liquefied, usually mixed with another chemical to help it liquefy, and then poured into a mold so that it would conform to that shape. The main process steps are mold preparation, where the mold, just like in thermoforming, is usually covered with a release agent. The polymer is mixed with the chemicals and it's degassed using a vacuum to remove air bubbles, and then it's poured into the mold. It's allowed to cure and is demolded. The advantage of this method is a very low cost, simple method with great help to achieve complex shapes. Only the problem is this is a very slow process, as it takes time to cure. The tolerancing itself is not the best due to surface imperfections and the potential for air bubbles. So these need to be taken in mind when using such a method. Dip coating is a process where a workpiece called the substrate is lowered into a solution that has a liquid polymer inside it. The main process steps are dipping, where the substrate is lowered into the solution. It's held there, that's called the dwell time, and it is withdrawn. Then it is drained with another solution to prevent pooling of the coating, and to maintain the surface finish. And then it is dried and cured, maybe sometimes with a UV light to lock in that shape. Advantages of this process: it's a cost-effective way. The amount of work pieces you can dip at the same time are very large. It adheres to complex shapes. So, for example, those nitrile gloves are made using this process. And this process is a relatively low waste because all the excess just drips right back into the substrate, into the solution. The disadvantage of this process is it requires a controlled environment where the temperature, humidity also needs to be controlled. Also, you're working with very hazardous chemicals, so ventilation needs to be very good, and you shouldn't allow for any dust in the building. Another issue, it has a relatively long drying time depending on the thickness of the piece, and is high maintenance as it needs the changing of the solution and often at very high periods, very low periods, I should say. These are the sources used for our presentation. Thank you.